we're going to go into the HSRP admin PCs and assign them static IP addresses. This first one will be 10.10.10.6. And we also need to change the subnet mask to a /26. We also need to set the default gateway. We're going to use the IP address 10.10.10.30. The /26 subnet gives us 30 usable IP addresses. So the .30 address is the last usable IP address in the range. So we're going to use that as our Hotspot routing protocol's virtual interface. That will be our default gateway. So for now, we'll just statically assign that IP address to these PCs. And then we're going to go into the routers and configure the Hotspot routing protocol. So now we come to HSRP admin to just modify, copy and paste the configuration and just modify the IP address from a 6 to a 7. Save the configuration, and now the PCs are ready to go. So now we're going to boot up all our devices, let them get loaded up, and then we're going to start the HSRP configuration. So we'll start with hswitch1. We'll give it its host name by using the hostname command in global configuration mode, followed by hswitch1. Then we'll enter line configuration mode and enter the logging synchronous command to keep our syslog messages looking clean. Then we're going to enter interface gigabit Ethernet 0/2's interface configuration mode to enter the switch port encapsulation .1q command, followed by the switch port mode trunk command to have the link between hswitch 1 and 2 act as a trunk link. So now we'll come over to hswitch2, configure the host name, followed by the logging asynchronous command in line configuration mode. And now we'll go into interface gigabit Ethernet 0/2, which is the port connecting to hswitch1. And we're going to enter the switch port trunk encapsulation .1q command, followed by the switch port mode trunk command to have this link act as a trunk link. So now we'll move into global configuration on the Hotspot Router 1. Give it the host name HSRP1. We'll enter router configuration mode with the router OSPF 50 command. We'll have this router participate in our OSPF configuration. We'll give it a router ID of 9.9.9.9. Now we'll go into the interfaces and assign them the IP addresses. and then also advertise their networks to the OSPF network. So the first interface we'll go into is Gigabit Ethernet 0/0 to enter the IP address 10.10.10.5, 255.255.255.224 command. We also have to enter the no shutdown command to enable the interface. And so now we have an active interface in our 10.10.10.0 network. We'll use the IP OSPF50 area 0 command on the interface so that this router will begin to participate in the configuration by advertising the network on the interface. And here we can see our adjacencies have formed, and now when we do the show IP route OSPF, we have our shared OSPF configurations. I had to turn a lot of them off for performance during this part of the video, but these are the current OSPF routes in our network. These bottom 8 subnets, as you can see, the switches are turned off. It also highlights an important concept for dynamic routing protocols. When I turn the VLAN 10 through 80 subnets router off, the dynamic routing protocol messages updated all of the OSPF routers with the current active routes. So when VLANs subnets 10 through 80 were shut down, the dynamic routing protocol updated all of the routers. We'll go back into Gigabit Ethernet 0/0's interface configuration mode to configure the Hotspot routing protocol. We enter the standby 30 IP 10.10.10.30 command. This is what sets the virtual interface's IP address that will act as the default gateway for our HSRP admin 1 and 2 desktops. We also have to set the standby version. We're going to set it to version 2. Then we're also going to give it the standby group name of HSRP with the standby 30 name command. And then we'll set the priority with the standby 30 priority 110 command. In the Hotspot routing protocol, the higher the priority is what determines if the router is active or not. So the router with the highest priority will be the active router, and the other router will be in standby mode. Now we get our syslog message letting us know that this is the current active router, changed its state from standby to active. We'll set HSRP2 with a lower priority, which makes HSRP1 the active router. Next, we need to go into the port facing HSRP2, so we use the interface Gigabit Ethernet 0/1 command to enter interface configuration mode. And then we use the IP address command to configure the IP address 10.44.44.1, 255.255.255.252. We enter the no shutdown command to enable the interface. That completes the HSRP configuration on HSRP1. Now we'll move into HSRP2 to configure its hot swap routing protocol. So first we'll go into the router and give it its host name of HSRP2 and enter the logging as synchronous man in line configuration mode. Then we'll enter the router OSPF50 command to enter router configuration mode. Now we set the router ID to 10.10.10.10. we'll go into interface gigabit Ethernet 0/1's interface configuration mode, which is the port facing HSRP1, to enter the IP address 10.44.44.2, 255.255.255.252 command. Then we use the no shutdown command to enable the interface. So now I use the do ping 10.44.44.1 command to verify that we have IP connectivity. There we can see we've got our response. The Hotspot routing protocol requires us to have this IP network in between the routers. We'll enter interface gigabit Ethernet 0/0's interface configuration mode to enter our HSRP commands. First, we'll set the IP address to 10.10.10.6, 255.255.255.224. We'll enter the no shutdown command to enable the interface, and then enter the IP OSPF 50 area 0 command to have it participate in our dynamic routing protocol. Now we enter the standby 30 IP 10.10.10.30 command. This will set our virtual IP address that's shared between HSRP 1 and 2. With the hot swap routing protocol, that virtual interface is what's used as our default gateway, which is why we statically assigned HSRP admin 1 and 2 that IP address for their default gateway. Next, we'll enter the standby version 2 command to set the version. And then we'll enter the standby name HSRP command to name the HSRP group HSRP. And then we'll set the priority to 90 with the standby 30 priority 90 command. This will configure HSRP2 to be in standby mode because it has a lower priority setting than HSRP1. So that will finish the hot swap routing protocol between HSRP1 and HSRP2. Now we can power on the HSRP admin 1 and 2 PCs, and while they're booting up, we'll move into the central router and we'll ping the virtual IP address of the HSRP network, and then we get a response, so that helps us to verify that the configuration is correct. We'll continue the testing by moving into the secure zone router and pinging the virtual IP address. And then we can see that we've gotten a response. We're also going to move back into the 192.168.254.0 desktops and try to ping the virtual IP address. Then we can see we've gotten a response. Now that HSRP admin 1 and 2 are booted up, we'll go into HSRP admin 2 to test ping the virtual IP address, and we get a response. Then we'll also go into HSRP admin 1, do a ping test, and we can see that we're getting a response. We use the interface range gigabit Ethernet 0/0-1 command to enter the interface configuration mode for the 2 ports, and then we'll shut them down. So what will happen is HSRP2 will move from standby mode to active mode, and the same virtual IP address is still active because we've configured it on both of the routers. So when HSRP1 goes down, we still have IP connectivity to the virtual IP address through HSRP2. So now we do a test ping after we shut down the interface from the 192.168.254.0 network. Then we can see we're getting a response. And then I come back to HSRP1, do a do show IP interface brief to show that the status is administratively down, which means that HSRP2 is now acting as the default gateway, the active router in the HSRP process. Back in HSRP2, we can see we got the syslog message there that the state went from standby to active. So that also verifies that our HSRP configuration was correct. So now we're going to use the interface range gigabit Ethernet 0/0-1 to enter the ports on HSRP2 and then shut them down. So now when we go back to the 192.168.254.0 network, do a test ping, it fails because none of the interfaces are up. We move back into the HSRP1 router and we're still in interface configuration mode for the ports that we shut down. So now we'll just enter the no shutdown command to re-enable the ports. So we'll get syslog messages that our interface is back online, but they still need to form their router adjacencies before IP connectivity can happen. So now when we go into HSRP1, we can see our neighbor adjacencies have just formed. So now the Hotspot routing protocol can be re-enabled. And so now when we do our test ping from HSRP admin 1, we get a response. We left this PC on the 192.168.254 network in a perpetual pinging state. So we didn't have to enter the command. It just started getting the ping responses and started displaying the output. And now when we end the ping command and look at the statistics, we can see of the 67 packets that were transmitted, only 11 of them were received because the interface wasn't active. We made the interface active, it started gathering the ping statistics. And then when we ended the command, it presented us the statistics for the ping session. We're still in the interface configuration mode for the ports on HSRP2. So we're going to re-enable them with the no shutdown command. We'll wait for the syslog messages to let us know the interfaces are up and the adjacencies are back. And that will conclude the HSRP testing that we'll be doing. In the video so far, we've configured these devices that are highlighted in blue. This represents the network that we have control over and could implement our administration policies like a IP addressing scheme, for example. This top switch represents the ISP switch, which we have no control over, and it's going to represent our default gateway to the internet. Basically, we'll have an IP address that none of the routers know, and then we'll have IP connectivity to it by relaying the default route information to all the other routers. So we will go in and do the initial configuration by giving it its host name of ISP and then entering the line console configuration mode to enter the logging synchronous command. So we're going to configure a loopback interface on this ISP switch to represent our IP address for the host that is out in the internet. So we give it this 209.165.16.17 255.255.255.0 IP address. And then we enter the no shutdown command to enable the loopback interface. And so now our goal is going to become to communicate with this loopback interface that is representing our host IP address somewhere out on the internet. We have to configure two different subnets, one connecting to HSRP1, one connecting to HSRP2. The port facing HSRP1 is gigabit Ethernet 0/0. So we'll start by going into interface gigabit Ethernet 0/0's interface configuration mode. And we enter the no switch port command to turn the port into a routed port. We'll then assign the IP address 10.55.55.2, 255.255.255.252. Now we'll move into HSRP1 to configure the port on the other side of the link, which is HSRP's gigabit Ethernet port 0/2. So we go into interface configuration mode to enter the IP address 10.55.55.1, 255.255.255.252 command. And then once we can see that we've set the IP address, we'll do a test ping. So I'll use the do ping 10.55.55.2 command. And then we can see that we get a response. We'll move back to HSRP2 and we're going to enter the interface configuration mode for the port facing the ISP. So it's going to be interface gigabit Ethernet 0/2. In the interface configuration mode, we enter the IP address 10.66.66.1, 255.255.255.252 command, followed by the no shutdown command to enable the interface. Now we'll go into the ISP switch to the port facing HSRP2, which is gigabit Ethernet 0/1. And we'll enter the IP address 10.66.66.2, 255.255.255.252 command, followed by the no shutdown command. So now we'll do a do ping 10.66.66.1 command to verify IP connectivity. And then here we can see we've got a response. During the video, I had to power down devices during the initial configuration to give me better performance. So now we're going to come back and turn a lot of these devices back on. When you look at my GitHub website for this video, it'll have the scripts for each device that you can download. So here I've got a script for dist1, the configuration for dist1. It's a simple text file. We open up the text file and then we just copy and paste the dist1 configuration from the text file directly into the console of the Cisco Modeling Lab. So we have to start in global configuration mode for these particular text files. So I copy it from the text file, right-click on the console and then paste. And now we can see the commands are being entered one at a time. And then as the device comes online, we'll get syslog messages about interfaces coming up, VLAN states changing their state to up, and neighbor adjacencies with the OSPF. I could have used a write memory or a copy running config startup config and then shut it down, but I wanted to demonstrate the copy and paste functionality that the Cisco modeling platform offers. When we start doing our test pings on the loopback interface, there needs to be a route from the loopback interface back into our network. So we're going to use the IP route 0.0.0.0.0.10.55.55.1 command. The 10.55.55.1 is our next hop IP, and then this is a default route. What that means is if the router doesn't have a route to the destination IP address, it will forward the traffic. In this case, the next hop IP address, which is 10.55.55.1. We'll also set another static route to HSRP2 using the next hop IP address of 10.66.66.1. And this is so that we can do our testing for exiting our network with a default route. We will be configuring default static routes on HSRP1 and HSRP2. We'll start with HSRP1. In global configuration mode, we enter the IP route 0.0.0.0, 0.0.0.0, 10.55.55.2 command. The 10.55.55.2 is our next hop IP address on the ISP. So now we need to go into HSRP2, configure a default static route on it. So we'll go into global configuration mode to enter the IP route 0.0.0.0, 10.66.66.2 command to configure the static route as having the next hop IP address of the ISP. With the OSPF routing protocol, you can designate a router to advertise the default route to all the other OSPF routers. The command also has a metric parameter, and the default information originate command with the lowest metric value will become the default route that is advertised. So when we enter the default information originate command, we'll come over here to the branch 1 router. When we do a show IP route, we can see at the top of the routing table, the gateway of last resort is set to 10.10.10.6, which is the IP address of the interface facing the 10.10.10.0 network off of HSRP2. The expansion router is one hop away from the 10.10.10.0 network. When we do the show IP route command to look at the routing table, we can see that the gateway of last resort is set to the interface of branch 1 facing the Snoop switch network. So what happened was the default route got pushed to branch 1. Branch 1 pushed the default route to expansion 1, letting it know what the next hop IP address is, which is 172.16.1.1. And then when it gets to the branch 1 router, the gateway of last resort becomes 10.10.10.6 to reach the default route, which then pushes it out to the internet to reach the 209.165.16.17 address. So now we'll ping the loopback interface on ISP1 from the 192.168.254.0 network. And we can see that we're getting a response. So even though we don't have a route to the 209.165 network, when the router can't find a route, it has a route for the default route, which sends all traffic that doesn't have a routable IP address to that default route to then be routed to its destination, if it exists. Now we've come back to HSRP1 to enter the default information originate command on it. The default metric is lower than 5. So what will happen when we enter this command with no metric parameter is it will have a lower metric than the one on HSRP2. With that lower metric, HSRP1 will now dictate the default information command. It will now relay itself as the default route. So we'll come over to the central router and we'll do a show IP route command. And then again at the top of the show IP route output, we can see the gateway of last resort has been set to 10.10.10.5, which is the HSRP1 interface facing the 10.10.10.0 network. So to get to the default network, you have to go to that 10.10.10.5 IP address. So since it had the lower metric, it now will replace this 10.10.10.6 route on all of the routers to the gateway of last resort being this 10.10.10.5. So the reason we did that is that if one of the routers were to go offline for some reason, then the other default information originate with the metric 5 would take over and the network wouldn't go down. We would just lose the one device and the network could keep operating. So now we can run a demonstration scenario where HSRP1 goes offline. So all of the network traffic now must flow through HSRP2. So when this happens, the ISP realizes HSRP1 is offline. So one of the internet service provider admins goes into the port facing HSRP1 and shuts the port down with the shutdown command. When this happens, there's a backup default static route with an administrative distance of 5. So when this interface is shut down, the IP routing table updates the gateway of last resort from 1055.55.1 to 10.66.66.1. And so now we lost HSRP1, but we still have our IP connectivity outside of our network, which is represented by IP connectivity to the loopback interface on the ISP. And we can see we're getting responses from our ping command, which means we still have IP connectivity outside of our network. There are features in the Cisco IOS platform that need a username password set. So we're going to go ahead and create one by using the username secret command. So first we enter the username mark to set the username to mark, followed by the parameter secret and the characters of the password. So there's my password in this case. The secret parameter takes your password and runs it through a hashing algorithm to produce a specific output. And then it saves that hash output in the startup configuration. So that way when you go to log in, you type in your password and it's put through the hashing algorithm, and if it matches the specific output, of the passwords, when it's run through the hashing algorithm, it's a match, and then you're allowed to log in. Another useful aspect of the parameter is that the hashed characters are saved in the startup configuration file, not the password. So when people are looking at the configuration file, they can only view the hashed characters and not your password. The last topic of the video is going to cover the spanning tree protocol. It's a layer 2 protocol, so we're going to be focused on this full mesh topology in the center of our main topology. The full mesh topology creates redundant links. This can create a situation where frames at the layer 2 level can loop indefinitely in the topology. The three main problems are broadcast storms, MAC table instability, and multiple frame transmission. Spanning tree protocol addresses these problems by assigning ports certain states depending on which switch is the primary root bridge. After the root bridge is defined, then the path that the frames take can be configured to not loop indefinitely in the network, creating the broadcast storms, MAC address table instability, and multiple frame transmission. So the root bridge is elected by winning the election process. The election is won by the bridge that is advertising the lowest bridge ID, which is the MAC address of the switch plus the VLAN that it operates in. And then the switch with the lowest bridge ID will become the root bridge. The root bridge will have all of its ports in a forwarding state. And then, as we can see here on a switch that's not the root bridge, one of its ports will be the pathway to the root bridge. In this case, it's Gigabit Ethernet 0/3. And then when we open the connectivity tab, we can see that Gigabit Ethernet 0/3 is connected to Core 4. So now we'll go into the Core 4 switch and enter a show spanning tree command. And the show output lets us know that all of the ports are in a forwarding state, which is an indication that it's the root bridge. And then it also has this message, this bridge is the root. And that lets you know that this is the root bridge for VLAN 1. So the different spanning tree modes are rapid per VLAN, spanning tree, regular spanning tree, and then just regular per VLAN spanning tree. And then there's also multiple spanning tree. So in global configuration mode, you would enter spanning -tree mode rapid -PVST, and that would enable rapid per VLAN spanning tree mode on the switch. Currently, Core 4 is the root bridge. The spanning tree commands allow you to have influence over the election process to determine which bridge is the root bridge. The root bridge ID consists of the VLAN plus the priority plus the MAC address. So if the priorities tie, the tiebreaker becomes the lowest MAC address. So what that means is we can change the priority parameter to influence the root bridge election. The default priority is 32,768. So if we use the spanning tree VLAN 1 priority command and set it to a value less than 32,768, that will allow the switch to win the election and become the root switch. We also have the option to enter the spanning tree VLAN 1 root primary command. What this does is it changes the priority on the switch to 24,576, which is a value lower than the default. So when you enter this command, it changes the priority to 24,576, allowing it to win an election where the other switches have the default setting. After we enter the command, we can see by the show output that all of the ports are in a forwarding state, which is an indication that this bridge is the root bridge. We can also see the priority that is 24,577. It's the 24,576 plus the VLAN value of 1, which gives it the 24,577 value. And then we also have this message that says the bridge is the root, which lets us know that now core 1 is now the root bridge. This will conclude the demonstration of the Cisco modeling platform that I've been doing to celebrate passing the CCNA exam. Thank you for watching.